Hey, Algebra 1, we're back with our UF4, Understanding Functions 4. This is our target, graphing functions. And this is an essential question. That's kind of an understatement. This is a really important one. How do you graph functions? So let's take a look at this thing. What if we have graphing functions using a given domain? So right away, let's look, before we even read the rest of this stuff, graphing, we know how to graph using a given domain. This right here is kind of an important one. What if I give you very specific X values to graph with? Okay, so the domain is a set of inputs or X values, and the range is a set of outputs or Y values. One way to understand a function and its features is to graph it, visualize it, right? What we're going to do is graph this function for the given domain. We're going to graph this function for the given domain. X plus 3y equals 15, with our domain being 0, 3, 6, and 9. In other words, all we have is X values. We have to find our Y values. If we didn't have that restriction, this would be a line that doesn't end. But we have a restriction. In other words, we only are going to have 4 points. What does that look like? That's a really good question. What we want to do, we've been given inputs in X. So we need to solve for Y. In other words, we need to make this look like Y equals something in terms of X. How do we do that? The first thing we're going to do is subtract X from both sides. Now, I am going to, let's go ahead. We'll just go like this. 15 minus X. And then we're going to divide both sides by 3, because it's 3 times Y, so the inverse operation, dividing by 3. And now what we need to do, you know what? I'm going to write it the other way. I like it better this way. Well, I'm going to do negative X plus 15, and you'll see why in a little bit here. Our second part, after we divided by 3, if I take this one, this is negative 1/3 X, and this is 15 divided by 3, which is 5. So we're simplifying. Oh, this is asking for fractions. 15 divided by 5. What we end up with, though, is Y equals negative 1/3 X plus 5. In other words, I have Y in terms of X. If I know what my X values are, I plug those in directly and find Y values. So let's do that. If I do that, if I plug 0 in for X, that's what this is saying, plug these values in for X and find your Y values. If I plug 0 in for X, I have negative 1/3 times 0, which is 0. 0 plus 5 is 5. So the coordinate I'm graphing is X is 0, and my Y value is 5. In my second bubble, I'm plugging in 3 for X. Negative 1/3 times 3 is negative 1. We'll try this again. Is negative 1. Negative 1 plus 5 is 4. So when X is 3, Y is 4. Let's check 6. If I plug 6 in, negative 1/3 times 6 is negative 2. Negative 2 plus 5 is 3. So when X is 6, Y is 3. Let's check 9, because we need to. Negative 1/3 times 9, that is negative 3. Negative 3 plus 5 is 2. So when X is 9, Y is 2. We need to graph this, and welcome once again to the world of goofy graphs, because each of these lines don't go by 1, they go by 2. So be very careful here. 0, 5 is actually right here, because X is 0, Y is 5. Then we have 3, 4. We have 6, 3. And we have 9, 2. Now, notice I'm not putting a line between these or through these, because what we were told was the domain only exists for these 4 points. So in other words, there's only 4 Y values to go along with that. There's only 4 coordinate pairs, and there they are. That's it. Don't put a line, no line. This is an example of a discrete graph, Okay, let's go ahead and move on. We got more work to do here. Why do you not connect points of the graph? That's just what I went over, right? And how would the graph be different if the domain was from 0 to 9, but included 0 to 9? What would happen in this case is you would end up with a line segment. A line segment, right? We'd have a line segment. And it would look a little something like this. It'd be closed at this end and then closed at this end, and would include all the values in between. Because it could be 0, 3, 6, 9, like we did before, but it also could be every little thing in between, an infinite number of values in between, and it would stop there. In other words, it's not going all the way, it's just stopping right there. All right. Let's look at this guy. It says graphing functions using the domain of all real numbers, which is kind of what I was getting at just a little bit. This is what you might be used to a little more, where just what does the entire graph look like if all x values are available to us? Well, how do we do this? If the domain of a function is all real numbers, and yes, there are imaginary numbers, keep that one in your back pocket. Any number can be used as an input value, producing an infinite number of ordered pairs to satisfy the function. What we don't want to do is draw an infinite number of points or plot an infinite number of points to find our line or our function values. Arrowheads are drawn at both ends to indicate how to represent an infinite number of ordered pairs if a domain is not provided. In other words, if I don't tell you that specifically the domain is this, you should assume that we're graphing on all real numbers. I know it's kind of weird that we're assuming stuff in math, but that's what we're doing, okay? How do we graph using all real numbers? Look, if it gives you step 1, step 2, step 3, this is how you do it, right? This is how you do it. Use the function to generate ordered pairs by choosing several values of x, plot enough points to see a pattern for the graph, and then connect the points with a line or smooth curve. Again, we're talking specifically when it's all real numbers, not just a specific domain like we talked about just a minute ago. If I do x squared, look at this. They have a bunch of x values that they got to find y values for. Well, -3 squared is 9, -2 squared is 4. So I end up going and making these coordinate points. And if I graph those coordinate points, you'll see that I have a nice curve. I can understand the shape if I'm given enough points, if I'm given enough coordinate pairs to work with. Okay, let's see how that, another way that this looks. What if we had f of x equals 3x minus 5, okay? And remember, f of x works like y in function notation. So we're plotting x comma f of x, like this says, but it also kind of means x kind of y. That's how we're going to graph them anyway. So if I plug in -1 to this, the value of the function when x is -1, this is how we write this. The f of -1 is just what I said. The value of the function when x is -1. It's a lot, but we'll get there. We'll keep working on it. So if I plug this in, I have 3 times -1, which is -3, and -3 minus 5 is -8. So when x was -1, y was -8. This is the kind of thing that you're used to. You've done this before, but maybe not this formally. That's why I'm making a big emphasis on this, all right? You might not have done this quite as formally, and that's okay. That's why we're here in algebra, to do this. If we plug 0 in, we have 3 times 0, which is 0. 0 minus 5 is -5. So when x is 0, y is -5, or f of 0 is -5. That's our next coordinate point. We're going to keep going down the line. The value of the function when x is 1. 3 times 1 is 3, minus 5 is -2. When x is 1, y is -2. We got to plug 2 in for x. 3 times 2 is 6. 6 minus 5 is 1. So when x was 2, y was 1. The value of the function when x is 3. 3 times 3 is 9. 9 minus 5 is 4. So when x was 3, the f of 3 was 4. We got to plug in for 4. The value of the function when x is 4. 3 times 4 is 12. 12 minus 5 is 7. So when x is 4, y is 7. Okay. Now remember, we are graphing this one on the whole domain of all real numbers. All we're trying to do right now is get enough points so we can kind of understand what this is going to look like. And if we do that, if we plot these, the points appear to form well, let's find out. It's a line, by the way. Okay, -1, -8, 0, -5, 1, -2, 2, 1, 3, 4, and 4, 7. Now, these appear to form a line. Again, we are plugging these in. This isn't, we didn't say that this is all the X values, all the inputs that exist to get outputs for. We were just trying to find example inputs because we are graphing on the entire domain of real numbers. This one, they appear to form a line. In this case, because it didn't give you a specific domain, we're going to draw a line. Again, a line through all the points. So let's go ahead and do that. And we're also going to put arrows at the end because that indicates that this line keeps going. It does not stop at the ends, right? It keeps going and keeps going to infinity. Now, infinity is a funny thing. Okay, infinity is a funny thing. When you hear infinity, you think a really big number, but infinity is all the numbers. It's everything, not just big. It's everything. Weird concept. That's all right. We're gonna keep going with this. All right. Here's what we're gonna do. We're gonna graph each function. I'm gonna give you 5 X values. This is not, again, this is not graphing on a limited domain. This is graphing on all real numbers. This example is, okay? I'm going to give you 5 X values and you're going to give me Y values and then get the shape and then draw the line from there. So in other words, I'm going to say X is going to be, let's see, -2, -1, 0, 1, and 2. And you find my Y values. So X is going to be -2, -1, 0, 1, and 2. And you're going to find my Y values. Go ahead and try it. I'm going to do this. I'm going to do the examples with you when you come back, but go ahead and give it a shot. Plot your points, draw your lines, or you draw your shapes based on those points. Go ahead. Okay. Now that we've come back and you've hit unpause here, we're going to plug these things in. I think number 4 is a little tougher one, to be completely honest with you, and that's okay. We're going to talk our way through this. This says y equals -x². In other words, let's plug an x value in here. Y equals negative, and then x is -2 squared. In other words, we have to square -2 first and then multiply it by -1, right? If you think about it, this is like -1 times x squared. Those are the same, this means the same thing. So x squared is 4. 4 times -1 is -4. -2, -4. -1 squared, -1 times -1 is a +1. +1 times -1 is -1. -1, -1. 0 squared is 0, and 0 times -1 is still 0. 1 squared is 1. 1 times -1 is -1. 2 squared is 4. 4 times -1 is also -4. So there's my other 2 points that I've got. And I've got a pretty good idea of what the shape is. This is a parabola, a parabolic shape. In other words, it looks a little bit like this. Okay, just like that. I'm not the best artist in the world. Just deal with it. You're going to be okay. Okay, that is what we're looking for. The next one may have been a little more straightforward. So let's go ahead and talk through this one too. All right. Let's find some values here. If x is -2, this is like y equals -4 times -2 plus 2. Well, negative times a negative is a positive. 4 times 2 is 8. 8 plus 2 is 10. So when x is -2, y is 10. We can do the rest of them. We're going to talk through the rest of them. -4 times -1 is +4. +4 plus 2 is 6. -4 times 0 is 0. 0 plus 2 is 2. 1 times -4 is -4. -4 plus 2 is -2. 2 times -4 is -8. -8 plus 2 is -6. I'm going to plot these points, but again, we didn't have a limited domain. We just need to know some values that are going to be on this function to see what it looks like. So -2, 10, -1, 6, 0, 2, 1, -2, and 2, -6. This again looks like a line because it is. That's like y equals mx plus b, right? Point slope form. We're going to draw a line through the points, put arrows at the end. Again, that's the best I'm going to do for lines. Okay. That is how we graph a function on an all real numbers domain. It's okay. We're going to practice. We're going to practice. Let's go ahead. Step into another part. Ooh, here we go. Here we go. You're going to need to use Desmos. Desmos is an app that's in your Securely locker. Or if you have a calculator, you know how to use it, you can do that too. If you have an iPad, you can get it from the Securely locker. If you're doing it from your own personal computer or a phone, you can do on the phone, you can do an app also, the Desmos app, DESMOS. DESMOS. Okay. And if you're on a computer, just go to desmos.com and we can type in the same things. So what I want you to do now is go to desmos.com or open the Desmos app, and we're going to plug these things in. I'm going to write this down to the side, and then we're going to talk about it here in a second. All right, go to the Desmos app or the website. All right, now that we're back with the Desmos app open, what we're going to do first is graph this function that it's asked us to. And it's saying y equals -half x plus 3. This is our first example. So I'm going to type that in. Y equals, now the negative sign here is the same as the subtraction, which is different than a calculator. I know that. -half. So I'm going to type it like this. -1 divided by 2. And you'll notice that I've got -half now, but you can see my cursor's in the denominator. I want to get out of that. What I'm going to do is hit the right arrow over there underneath functions, and you'll notice how it moves away. I want -half x plus 3. And what we're trying to do is, what is the y value when x equals -2? That's what the book was asking, right? So what you're going to do is you're going to put your finger right on that line, and you're going to see something really cool. You're going to see x and y values, and you can trace. You can go back here and trace. So we're going to figure this out. When x is -2, oh, hey, there we go. Y is 4. When x is, oh, hold on. See if I can move my finger just a little bit. Oh, too far. When x is -2, y is positive 4. I like it. I like it. And then it makes sense, right? If we're looking on this graph, that looks like -2, 4. So the first blank we're saying, when x is -2, y is positive 4. The second function we're going to type in here, going to get rid of this one, is y equals y equals 3/2 x. So 3 divided by 2. Oh, hold on, let's try that again. 3 divided by 2. Got to move my cursor out, so I hit that over there. 3/2 x minus 4. Ooh, this is interesting. It looks like it's going off of the page. So let's go ahead and take a look at this real quick. You can see in Desmos is nice because I can move this anywhere I would like to. Anywhere I would like to. I'm going to put my finger right again on the graph. We're trying to find when x is -2, what is y? I think it looks a lot like it's going to be right in here. Let's see what happens. Let me get my finger on the graph here. When x is -2, y, oh, there it was, is -7. And that makes sense. That's where it looks, right? When x is -2, y is -7. That's the value when we trace using this graph. We're also going to do this when it looks like if we have a graph, or if you do graph some stuff, what happens? So go ahead, go back to your book. Let's take a look. So you'll notice that that first one that we did right up here, when x is -2, y is 4, that's the same thing we saw. The second one, we're going to talk about how to do this here in a second. But the second one, when we graphed it, we put it in Desmos and we said when x was -2, y was -7. Okay. So what your job is to go to Desmos right now and type in this function. Y, again, you could do f of x, you could type in y equals negative x plus 7, right? And when x this time is 3, so trace your finger along. When x is 3, what is your y value? I'll give you a second to go ahead and do that and come back with the answer. Now that you've come back, what we're going to do is look at that. You should have gotten 4. In other words, the value of the function when x is 3, the f of 3 essentially, is negative times 3 plus 7, which is 4. So the value of the function when x is 3 is 4. Okay, you can use your algebra to check that too, right? But that's a kind of a key thing, tracing on a graph. Let's keep it going. Let's keep it going here. When you see these puzzle pieces, this is pretty important stuff, all right? So modeling real world situations. Sometimes we want to have just reasonable answers, right? We've talked about this, right? Reasonable domains and ranges. We've talked about how, like, when you're selling tickets, you don't sell negative tickets, right? You don't make negative hockey pucks, things like that, right? So let's talk about those reasonable answers here. Most of the time, or some of the times, we have domains and ranges that are non-negative. In other words, we're working in quadrant 1. Quadrant 1 is when both x and y are positive. This is an example of it down here in the bottom right. This example says the mid-Atlantic ridge separates North and South American plates from the Eurasian and African plates. The function y equals 2.5x relates the number of centimeters y the mid-Atlantic ridge spreads after x years. Graph the function and use the graph to estimate how many centimeters the mid-Atlantic ridge spreads in 4.5 years. Okay, the function is y equals 2.5x, and we're trying to find how, this is how much it spreads after x years. Okay, we're gonna figure it out in 4.5, and that's okay though. We're only going to use positive values of an x and y when we graph this. We're going to use positive values. We're going to use the graph to find the value of f of x, or y, which is y, when x is 4.5. Now, could we plug this right in and solve? Yeah, but that's not the point of this right now, okay? We're going to choose some different values here to make our line. If x is 0, 0 times 2.5 is 0. I got 0, 0. Okay. When x is 2, 2 times 2.5 is 5. So it's 2 comma 5, 2, 5, 4 times 2.5 is 10. So when x is 4, y is 10. So I'm sorry, 4 comma 10. I got excited there. 4 comma 10. When x is 5, 5 times 2.5 is 12.5. So when x is 5, y is 12.5. And you can see that this is a graph, a line, right? And we're not going to draw anything negative. What we're going to do is draw it all in the positive, all in the first quadrant. It starts at 0, 0 and moves out that way. It doesn't always have to start at 0, 0, but it's never going to be negative. What we're going to do is estimate, okay? We're going to estimate here when x is 4.5. So this is when 4.5 is like right here, right? The y value here is like, I don't know, 11? 11? Well, it's going to be somewhere, well, 4.5 is between 4 and 5. So halfway between 10 and 12.5 should be about 11.25, which it looks like. Again, we're just estimating here. All right. So we drew the line through the points. This is a situation that is continuous. We can do that through all the points because the points appear to form a line. And so what we did is we estimated the line spreads about 11.25 centimeters after 4.5 years. Okay. Does it make sense? The distance of 11.25? Does it make sense? Absolutely. Absolutely, it's reasonable because X is somewhere between 4 and 5, it's halfway in between. And those values, that value is halfway between the Y value, halfway in between the Y values of those two. Y is between 10 and 12 and a half. Since it's between 4 and 5, we're going to estimate to be about 11.25 between those things. All right. So I don't let this one drag on too long. What I want you guys to do, go ahead and try number 7. I'm going to give you some X values to look at. I'm going to give you some X values to look at. I'm going to say 0, 1, 2, and 3 as your X values. Now's a good time to hit pause, try this out on your own, come back when you're done. All righty, let's finish this guy up, okay? What we're gonna do here is plug these values in. So Y equals 15 times 0 plus 5. Well, 15 times 0 is 0, plus 5 is 5. So when X is 0, Y is 5. When X is 0, Y is 5. When X is 1, I have 15 times 1 plus 5. Well, 15 times 1 is 15, plus 5 is 20. So when X is 1, Y is 20, 1 and 20. When X is 2, I have 15 times 2 plus 5. So 30 plus 5 is 35. When X is 2, Y is 35. When X is 3, 15 times 3, 15 times 3 plus 5. 15 times 3 is 45, plus 5 is 50. So when X is 3, Y is 50. When X is 3, Y is 50. Now, distance away from a port. A ship does not teleport. I used port twice. It doesn't teleport. It doesn't just go from this spot to this spot. It goes continuously in between. This is another continuous situation. And we didn't have a limited domain. We can draw the line through these things. We're going to estimate how far the cruise ship will be from its port 2.5 hours from now. So 2.5 right here is here in X. And then in Y values, that's somewhere in between those two things. Well, this is 45. It's somewhere between 40 and 45, it looks like. So let's go halfway between 40 and 45. Let's call it 42.5. So let's say at 2.5, Y is going to be 42.5. What does that mean? So after 2.5 hours, the ship is 42.5 miles, or kilometers, there we go, we're using correct units here, kilometers from port. So there we go. We just use it, right? Distance from port. We used our logic. We used everything that we needed to in there. All right. A lot of this is building on what you've learned in middle school and some in geometry. It's okay if you got questions. That's why I'm here. Let's do this thing. I'm going to give you the practice problems that I want you guys to do in practice 1. But yeah, knock it out. Take care. Have a great day.